Class 2 and Class 3 wiring can indeed be used in certain types of fire alarm systems. However, it's important to understand the limitations and specific applications for each class. Class 2 and Class 3 wiring are not typically rated for 2 IOs of fire resistance. If your application demands 2 IO fire resistance, consult the National Electrical Code, or NEC, for specific requirements regarding fire-rated cables and installation methods. The NEC provides detailed guidelines to ensure the integrity of fire alarm systems during a fire event. Now let's discuss the maximum voltage allowed on each type of cable. For Class 2 wiring, the maximum voltage allowed is 600 volts. For Class 3 wiring, the maximum voltage allowed is 150 volts. Understanding these voltage limits is crucial for selecting the appropriate wiring for your fire alarm system and ensuring compliance with electrical safety standards. Always consult the NEC and local electrical codes for the most up-to-date requirements and best practices. When dealing with fire alarm systems, safety is paramount. Using the correct wiring and installation techniques is essential for the reliable operation of the system in the event of a fire. Remember that simply using Class 2 or Class 3 wiring does not automatically guarantee compliance with fire safety regulations. The entire system must be designed, installed, and maintained in accordance with applicable codes and standards. Be sure to consider the ambient temperature rating of the cable. Cables have a maximum temperature they can withstand before their insulation begins to degrade. The NEC outlines acceptable temperature ratings for different applications. Select wiring with a temperature rating appropriate for the environment in which it will be installed. This is especially important in areas where temperatures may exceed normal limits, such as near heat sources or in direct sunlight. Also consider the cable's listing and labeling. Ensure the cable you choose is listed and labeled by a recognized testing laboratory, such as UL or ETL. This listing indicates that the cable has been tested and meets the applicable safety standards. The label will also provide important information, such as the cable's voltage rating, temperature rating, and intended use. Be careful when running Class 2 or Class 3 cables alongside power conductors. The NEC specifies requirements for separating low-voltage wiring from high-voltage power conductors to prevent interference and ensure safety. Maintain the required separation distances and use appropriate barriers or conduits when necessary. When terminating Class 2 or Class 3 wiring, use connectors and terminals that are specifically designed for the type and size of conductor being used. Ensure that connections are tight and secure to prevent loose connections, which can cause overheating and malfunction. Follow the manufacturer's instructions for proper termination techniques. Inspect the wiring regularly as part of a comprehensive maintenance program. Look for signs of damage, such as cuts, abrasions, or discoloration. Replace any damaged wiring immediately to prevent potential hazards. Regular inspections can help identify problems before they escalate and compromise the integrity of the fire alarm system. When working with fire alarm systems, it's always best to consult with a qualified electrician or fire alarm technician. These professionals have the knowledge and experience to ensure that the system is installed and maintained in accordance with all applicable codes and standards. Their expertise can help you avoid costly mistakes and ensure the safety of your building and its occupants. Fire alarm systems are critical life safety systems, and their proper functioning is essential for protecting people and property. By using the correct wiring, following proper installation techniques, and maintaining the system regularly, you can help ensure that it will perform reliably when needed. Remember to always prioritize safety and consult with qualified professionals when working with fire alarm systems. Class 2 and Class 3 circuits are defined by their power limitations, with Class 2 circuits having lower power levels than Class 3. These power limitations dictate the types of wiring methods that are permitted and the level of protection required. The NEC provides detailed tables and calculations for determining the power limitations of Class 2 and Class 3 circuits. Ensure that your fire alarm system complies with these limitations to avoid potential hazards. The type of insulation used on Class 2 and Class 3 wiring is also important. The insulation must be suitable for the voltage and temperature conditions of the application. Common insulation materials include PVC, polyethylene, and cross-linked polyethylene. Select an insulation material that is resistant to moisture, chemicals, and abrasion to ensure long-term reliability. The size of the conductor used in Class 2 and Class 3 wiring is determined by the ampacity requirements of the circuit. Ampacity is the current carrying capacity of a conductor, and it is affected by factors such as the conductor's material, size, and insulation type. The NEC provides tables that list the ampacity of various conductors under different conditions. Select a conductor size that is adequate for the load being served to prevent overheating and voltage drop. When installing Class 2 and Class 3 wiring, be sure to follow proper routing and support methods. The wiring should be supported at regular intervals to prevent sagging and strain. Avoid running the wiring in areas where it could be subject to physical damage or exposure to moisture. Use appropriate conduits, raceways, or cable trays to protect the wiring and maintain a neat and professional appearance. The color coding of Class 2 and Class 3 wiring can help to identify the different circuits and functions within the fire alarm system. While the NEC does not mandate specific color codes for these circuits, it is common practice to use different colors to distinguish between power, signal, and control circuits. Use a consistent color coding scheme throughout the system to avoid confusion and facilitate troubleshooting. Proper grounding is essential for the safe and reliable operation of any electrical system, including fire alarm systems. Class 2 and Class 3 circuits must be properly grounded in accordance with the NEC. Grounding helps to protect against electrical shock and prevent the buildup of static electricity. Ensure that all grounding connections are tight and secure. Surge protection devices can help to protect Class 2 and Class 3 circuits from voltage surges caused by lightning or other electrical disturbances. These devices divert the surge current to ground, preventing damage to sensitive electronic equipment. Consider installing surge protection devices on fire alarm systems, especially in areas where lightning is common. Regularly test the fire alarm system to ensure that it is functioning properly. Testing should include all components of the system, including the wiring, detectors, control panel, and notification appliances. Follow the manufacturer's recommendations for testing procedures and schedules. Keep detailed records of all testing and maintenance activities. When making modifications or additions to a fire alarm system, be sure to comply with all applicable codes and standards. Obtain the necessary permits and inspections before starting any work. Use qualified electricians and fire alarm technicians to perform the work. Document all changes to the system and update the system drawings accordingly. The National Fire Protection Association, or NFPA, also publishes standards related to fire alarm systems. NFPA 72 is the National Fire Alarm and Signaling Code, which provides comprehensive requirements for the design, installation, testing, inspection, and maintenance of fire alarm systems. Consult NFPA 72 for detailed guidance on all aspects of fire alarm system design and installation. Remember that fire alarm systems are complex and critical life safety systems. Proper design, installation, and maintenance are essential for ensuring their reliable operation in the event of a fire. Always prioritize safety and consult with qualified professionals when working with fire alarm systems. In summary, while Class 2 and Class 3 wiring can be used in fire alarm systems, they do not inherently provide a 2I or fire resistance rating. Such ratings require specialized fire-rated cables and installation methods as dictated by the NEC. Furthermore, adhere to the maximum voltage limits, being 600 volts for Class 2 and 150 volts for Class 3, to ensure safety and code compliance. The NEC Article 725 covers requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are characterized by their voltage and power limitations, which determine the wiring methods and protection required. The NEC defines the specific voltage and power limits for each class of circuit. Class 2 and Class 3 circuits are considered low-energy circuits and are often used for applications such as doorbells, thermostats, and fire alarm systems. The lower energy levels of these circuits reduce the risk of electrical shock and fire, allowing for the use of less expensive and less robust wiring methods. However, it is important to note that even though Class 2 and Class 3 circuits are considered low energy, they still pose a risk of electrical shock if not installed and maintained properly. The NEC specifies requirements for overcurrent protection of Class 2 and Class 3 circuits. Overcurrent protection devices, such as fuses or circuit breakers, are designed to interrupt the flow of current in the event of an overload or short circuit. The size of the overcurrent protection device must be selected based on the ampacity of the conductors being protected. The NEC also specifies requirements for grounding of Class 2 and Class 3 circuits. Grounding helps to protect against electrical shock and prevent the buildup of static electricity. The grounding conductor must be sized and installed in accordance with the NEC. The wiring methods permitted for Class 2 and Class 3 circuits are specified in the NEC. These wiring methods include the use of listed Class 2 or Class 3 cables, as well as other wiring methods such as conduit, raceway, and cable trays. The wiring method must be suitable for the environment in which it is installed. The NEC also specifies requirements for the separation of Class 2 and Class 3 circuits from other circuits. Class 2 and Class 3 circuits must be separated from power circuits and other circuits that operate at higher voltages. This separation helps to prevent interference and reduce the risk of electrical shock. The NEC also specifies requirements for the identification of Class 2 and Class 3 circuits. Class 2 and Class 3 circuits must be identified with appropriate markings or labels. This identification helps to ensure that the circuits are properly installed and maintained. When working with Class 2 and Class 3 circuits, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for the design, installation, and maintenance of these circuits. By following these requirements, you can help to ensure the safe and reliable operation of the circuits.